Chapter Motion in Plane. Now to see one topic. Derive equation of motion of body moving in two dimension. Vector v is equal to vector v0 plus vector a t and vector r is equal to vector r0 plus v0 vector into t plus 1 half gt square. Consider a particle moving along xy direction with constant acceleration. Vector a at time t is equal to 0, the velocity is initial velocity, which is vector v0, and at time t is equal to t, the velocity is vector v. You can see in figure, at t is equal to 0, initial velocity v0, and at t is equal to t, the velocity is v vector. Acceleration is here a. So you can see in time and velocity graph, since the particle is moving with constant acceleration, the instantaneous acceleration can be written as, therefore vector a is equal to vector v minus v0 vector upon t minus 0. Therefore vector a is equal to vector v minus vector v0 upon t. Therefore vector v is equal to vector v0 plus vector at, equation 1. Writing this equation in terms of its component, Vx is equal to Vox plus Axt, equation 2. Vy is equal to Voy plus Ayt, equation number 3. Let at t is equal to 0, the position vector of the particle is given by vector r0, and at t is equal to t, it is vector r. The average velocity in time t can be written as vector v0 plus vector v upon 2. Displacement in time t is given by, is equal to average velocity into time. Therefore vector displacement in time t is given by, is equal to average velocity into time. Therefore vector r minus vector r0 is equal to, in bracket, vector v0 plus vector v upon 2 bracket over into t, equation number 4. Substituting equation 1 in 4, we can get r minus r0 is equal to in bracket vector v0 plus, in bracket v0 vector plus a vector t bracket over upon 2 bracket over into t, is equal to in bracket 2v0 vector plus vector a into t square upon 2 bracket over. Therefore vector r minus vector r0 is equal to vector v0 t plus 1 half vector a t square. Therefore vector r is equal to vector r0 plus vector v0 t plus 1 half vector a t square, equation 5. Writing this equation in terms of component, x is equal to x0 plus v0 xt plus 1 half axt square, equation number 6. Similarly, y is equal to y0 plus v0 yt plus 1 half ayt square, equation 7. It is clear from the equation 6, 7 that the direction of motion of x and y are independent. What do you mean by projectile motion and projectile particle? Question mark. Find the value of the position of the projectile particle at any instant of time. When an object is thrown in a gravitational field of the earth, it moves with constant horizontal velocity and constant vertical acceleration. Such a two-dimensional motion is called projectile motion, and such an object is called an projectile object. For example, when we kick a football, it performs projectile motion. If air resistance is neglected, first, a projectile has motion along horizontal path with constant velocity. Second, a projectile has motion along vertical path under gravity with constant acceleration equal to g. Suppose that the projectile is launched with velocity v0 vector that makes an angle theta 0 with x-axis as shown in the figure. You can see in figure. G gets on the body along y-axis and in opposite direction. The acceleration a is given by vector A is equal to minus G unit vector J. The velocity vector V0 can be divided into two components. V0x is equal to V0 cos theta 0 equation 2, and V0y is equal to V0 sin theta 0 equation number 3. You can see in figure. If we take the initial position to be the origin of the coordinate system, the coordinates of the point of projection would be x0 is equal to 0 and y0 is equal to 0. If at time t projectile is at q, then its x component can be written as x is equal to x0 plus v0x into t plus 1 half ax t square, and y is equal to y0 plus v0y t plus 1 half ayt square. Therefore x is equal to in bracket v0 cos theta 0 bracket over into t equation 4, and y is equal to v0 sin theta 0 in bracket into t minus 1 half gt square equation number 5. At q, vx is equal to vox plus axt and vy is equal to v0y plus ayt. We get vx is equal to v0x is equal to v0 cos theta 0 equation 6, and vy is equal to v0y minus gt. Therefore vy is equal to v0 sin theta 0 in bracket minus gt equation number 7. Here equation 4 and 5 gives the position of the projectile at any instant of time, and equation 6 and 7 gives the value of the velocity along x and y direction. Define projectile particle and derive the equation y is equal to in bracket tangent theta 0 bracket over into x minus g upon in bracket v0 cos theta 0 bracket over square into x square. When an object is thrown in a gravitational field of the earth, it moves with constant horizontal velocity and constant vertical acceleration. Such a two-dimensional motion is called projectile motion, and such an object is called projectile. Let the distance traveled by the object at time t using with v0 given by x is equal to in bracket v0 cos theta 0 bracket over into t equation 1. Let the distance traveled by the projectile along the y direction be given by y is equal to in bracket v0 sin theta 0 bracket over into t minus 1 half gt square equation number 2. You can see in figure also. From 1 t is equal to x upon v0 cos theta 0. Keeping this value of t in equation number 2, we get y is equal to in bracket v0 sin theta 0 bracket over next bracket x upon v0 cos theta 0 bracket over minus 1 half g in bracket x upon v0 cos theta 0 bracket over square. Therefore y is equal to x tangent theta 0 minus 1 half g upon in bracket v0 cos theta 0 bracket over square into x square equation number 3. Here v0 theta 0 and g all constant, and equation 3 can be compared with y is equal to ax plus bx square, which is an equation of parabola. Hence we can say that the path of the projectile is parabola. You can see in a figure also. Derive the formula for time taken to achieve maximum, total time of flight and maximum height attained by the projectile. Time taken to reach the maximum height h to be t max. At maximum height, the y component of the velocity vy of the projectile is 0. We get vy is equal to v0 sin theta 0 minus gt. From equation v is equal to u plus at. vy is equal to v0 sin theta 0 minus gt. At t is equal to tm, Vy is equal to 0, therefore 0 is equal to V0 sin theta 0 minus GTm. Therefore GTm is equal to V0 sin theta 0. Therefore Tm is equal to time for maximum height. Tm is equal to V0 sin theta 0 upon G. Equation 1 you can see in figure, that is velocity, initial velocity V0 at maximum height, that is Vy is equal to 0. Total time of the flight is given by, let it will be Tf. Substituting y is equal to in bracket V0 sin theta 0 into t minus 1 half gt square. When y is equal to 0, then t is equal to Tf. Therefore 0 is equal to in bracket V0 sin theta 0 bracket over Tf minus 1 half g Tf square. Therefore 0 is equal to V0 sin theta 0 minus 1 half g Tf. Therefore time for total flight Tf is equal to 2 V0 sin theta 0 upon g. Maximum height in projectile motion, the maximum height attained is shown in figure. You can see in figure, this is h. The distance travelled by the body in vertical direction is given by y is equal to in bracket V0 sin theta 0 bracket over t minus 1 half gt square. Keeping t is equal to Tm, we have then y is equal to h. Therefore h is equal to in bracket V0 sin theta 0 bracket over Tm minus 1 half g Tm square. Substituting the value of Tm from equation 1, we get h is equal to in bracket V0 sin theta 0 bracket over into Tm minus 1 half g Tm square. Therefore h is equal to in bracket V0 sin theta 0 bracket over next bracket V0 sin theta 0 upon g bracket over minus 1 half g in bracket V0 sin theta 0 upon g bracket over square. From equation number 1, therefore h is equal to V0 square sin square theta 0 upon g minus V0 square sin square theta 0 upon 2g. Therefore h is equal to V0 square sin square theta 0 upon 2g. That is the equation of maximum height. Derive the formula for range of projectile R. Range is defined as the horizontal distance travelled by the projectile from its initial position x is equal to y is equal to 0 to the final position it passes y is equal to 0 during its fall, is called the range of the projectile, or it is the distance travelled from its initial position x is equal to 0, y is equal to 0 to final position x is equal to r and y is equal to 0 is called r. At any instant of the time keeping x is equal to r and t is equal to tf, therefore x is equal to in bracket v0 cos theta 0 bracket over into t, therefore r is equal to in bracket v0 cos theta 0 bracket over into tf. Therefore r is equal to in bracket v0 cos theta 0 bracket over next bracket 2v0 sin theta 0 upon g bracket over. Therefore here given, that is tf is equal to 2v0 sin theta 0 upon g. Keeping this value, we can get r is equal to 2v0 square sin theta 0 cos theta 0 upon g. Therefore r is equal to v0 square in bracket 2 sin theta 0 into cos theta 0 bracket over upon g. Therefore r is equal to v0 square sin 2 theta 0 upon g. Therefore r max is equal to v0 square upon g, where sin 2 theta 0 is equal to 1. Therefore r is equal to v0 square sin 2 theta 0 upon g, equation 1. Therefore r max is equal to v0 square upon g, where sin 2 theta 0 is equal to 1. Therefore for r max sin 2 theta 0 is equal to 1. Therefore 2 theta 0 is equal to 90. Therefore theta 0 is equal to 45. If the object is projected at angle theta 0 is equal to 45 degree, then its range is maximum. The value of r max depends upon its initial velocity.